Good morning, good afternoon, or good evening, depending on when and where you're watching this recording. Today, we're going to talk about deploying Azure DevOps using Terraform and some of the lessons learned that I found while doing it. So let's begin today. First, our agenda that we're going to cover. We're first going to talk about some of Microsoft's investments in Terraform, where that sits, and why that's important. We're going to talk about the Azure Terraform provider itself and the roadmap, because there's lots of interest around this. We're also going to talk briefly about the next version of Terraform so that you're in the loop and know what's coming down the pipe so you can kind of prepare for your projects and your future-proof coding. And then we're going to talk about the various Azure DevOps components, what we can't deploy, and actually see that in action. And then finally, we're going to wrap up with some resources that will be valuable for you in your learning adventures. So let's begin. Firstly, we want to stress about Microsoft's investment in Terraform. We want to really iterate for people that Microsoft loves Terraform. In fact, for those of you that might not be aware, Microsoft has a dedicated team of individuals specifically focused on the updates and enhancements and improvements to the Azure Terraform provider. So we have a team on the Microsoft side, and there's a team on the HashiCorp side that obviously is working on the Terraform language itself. And these two teams work together to enhance the Terraform provider for Azure and also incorporate any updates, improvements, and changes throughout. So as an example, to show how much Microsoft invests in Terraform, the goal is for it to be what we call a first class citizen, where it is up there at the same level on par with our Azure specific templating language called ARM. So as an example, the last or latest release of the Azure provider for Terraform was August 5th. It's version 2.21. In that release, there were 59 enhancements and bug fixes to the provider. And in July, there were five releases or updates that were published. So generally it's once a week, but obviously it's flexible based on the needs, and we are continuing to iterate and build into the provider additional feature sets, which we'll show in a moment. Also, in case you're not aware, HashiCorp has a public module registry for Terraform. The link is right here on the screen. And if you go to that link, specifically you're searching for the Azure provider, those modules are actually authored by Microsoft and committed or published and given to the community to use. So we have modules for deploying virtual networks and the subnetting. We have modules for virtual machines and so forth. And these have been authored by the same Microsoft team that's responsible for the Terraform Azure provider. So they've been tested, they've been validated to be able to use with the community. Let's just touch a little bit on the roadmap for the provider itself, because many people kind of want to know, hey, what's going to happen in the future? When is this feature going to come out? When is this going to happen? So if you go to the public GitHub repo where the Terraform provider sits for Azure, you can look under milestones to see not only when the next version is scheduled or planned to be released, but you can also go into it further to see what is going to be released in that update. So we have the example of version 2.22, which is due to be released tomorrow, August 6th. And in there, we see there's bug fixes, there's enhancements to, say, documentation, there's new resources being provided, enhancements to existing resources, and so forth. So you can see this in a public way, how we're progressing to add more into this, to add more feature sets, or iterate on top of it when, say, Azure releases a new feature set, for example, or new feature or property for a resource, being able to get that into the Terraform provider as quickly as possible so that you can leverage Azure and Terraform together. Now let's touch on the next version of Terraform. If you're not aware, this is version .13. Now this is still in beta. HashiCorp has released it in beta for people to try, but some of the nice feature sets that we are expecting out of this that has been publicly mentioned by HashiCorp is being able to use count, depends on, and for each specifically with modules. Now we could already use that in our normal Terraform code in resource declarations, but being able to use this with modules gives us a lot more flexibility in reusability for our code. So it's exciting to see. Another really nice enhancement is the custom variable validation. So we see the screenshot at the bottom there where we have a variable declared for image ID. Now this example is for AWS, but we have type and description, but we have a validation block within that variable declaration, and we're giving it a condition that it needs to match or check against. So that way, if we are writing a module that we will publish publicly, whether we're publishing it to the Terraform module registry publicly, or maybe we're using, say, Terraform Enterprise in our internal organization, and we are publishing a module that other teams can leverage, right? We can build validation into the variable so as things are passed and executed against our module, there's a better user experience. You don't want it to partially execute the module just to come back and say, oh, this variable did not have the proper type of input or the proper parameter input for that to actually execute, and have a partial deployment that's not very clean. So having this validation really enhances our user experience in executing against that. So that's a nice addition that we look forward to in the .13 release. Now we're going to start to dive into the Azure DevOps components and what we can and can't deploy. We're going to go through some code examples, and then we're actually going to execute this live. So on the left, things that we currently can deploy through the Azure Terraform, the Azure DevOps Terraform provider, which is currently in version 0.0.1. So it's the very first iteration. Of course, there's going to be gaps, there's going to be bugs, but it's nice to see what we already can deploy with it. So we can deploy things like projects and repositories, variable groups, pipelines, service endpoints, and things like these. We cannot yet deploy things like boards or environments or test plans or artifacts. So just keep that in mind if you're planning to leverage this in a production way, what we can and can't deploy just yet as the product team iterates on top of that provider to bring these other features to light and availability. The first thing I want to talk about when leveraging the provider itself is the need for certain environment variables on your execution. So you need at least two of these. The first two. So the first one is the Azure DevOps Personal Access Token, or PAT for short. This is what allows your current execution credentials. So if you're going from the command line doing Terraform init and Terraform plan and apply, this allows those credentials to be able to go into your DevOps organization through the API and create a new Azure DevOps project. There's a link on this slide here about how to use this personal access token specific to Azure DevOps. Coupled with that is the Azure DevOps organization service URL. This is very simply the org URL that you're referencing where the project will be deployed because you're creating a new project inside an existing organization. You're not creating a new Azure DevOps organization itself. So we see in my example on the screen, it's dev.azure.com slash your organization name. In my case, it's just my name. Third, we have the GitHub Service Connection Personal Access Token, or PAT. This is used if you're going to use GitHub for an acceptance testing mechanism. Now, I don't do that in my demo today or in my code, but it's there for reference if that's something that you want to explore. Now let's get into the code. This is the code specifically for creating an Azure DevOps project. So we see in the left-hand side the project name, description, we have a visibility if we want it to be public or private, what version control mechanism we're planning on using. Git is the default. What work item template structure we want to use. Agile is the default, but we have other options we can use. And then we have the features block. This controls what is enabled or available within that project specifically. So Azure boards, the repos, the pipelines, and so forth. Now notice the other screenshot on this slide. We can either declare the feature set for the project within the Azure DevOps project resource object, or we can create a separate resource block specific for Azure DevOps project features. Both options will work. You obviously can't use them at the same time, but both ways will work. So it's completely on personal preference which one you would feel you want to have your code structured like that. Personally, I think it makes more sense to keep it as the first example where it's in line with the project itself because it controls the features of the project. But again, it's personal preference. Both options are viable and will work with your code execution. Now let's look at the code for creating a DevOps repository. And this is a little bit of an interesting scenario and some interesting lessons learned that I found going through this. Now we have the first bit of code that creates a brand new repo native inside Azure DevOps. We do an initialization so it's ready to go. Notice the code at the bottom though. This is where we're trying to use the import initialization, and we're trying to reference an existing GitHub repo. So I tried going through this with one of my public repos, but unfortunately it didn't work. And I want to just call out that the public documentation for this is a little unclear and a little confusing. So as an example, the source type, where I have it set to Git, there's an example where it can be Git or GitHub or something else, and it's not clear what it exactly needs to be or what the viable or possible value should be. Also, the public documentation has an example, a code use example for using this import type. But through my testing, it didn't work. And through a little bit more digging into the issues that were filed on the public repo for the provider, I was able to interact with the product group and learned that unfortunately, the import repo functionality is not yet there. So again, the public documentation, little unclear and confusing because it gives you an example of using import when that functionality does not yet exist or is not enabled. So keep that in mind. That's a little bit of a limitation today. Now we're going to talk about the variable groups within Azure DevOps. These control what the pipeline can leverage and unifies kind of some of the command lines and so forth. So I have two examples of variable groups. This first one is linked to an Azure Key Vault that contains sensitive information, things like our storage access keys, our SPN password, maybe a default admin password that we want to have on virtual machines when they're created. That's the linkage to Key Vault. The other example in the bottom right is a separate variable group, but now I'm actually declaring the name and the value that goes into that variable itself. So interesting point here with the example in the bottom left linking to Key Vault, I am declaring the variable name and that name matches the secret name that's in Azure Key Vault itself so that it can make that linkage and allow the pipeline to be able to access the value from Azure Key Vault. Same thing with the allow access property here set to true to allow all the pipelines to be able to use this variable group that is linked to Key Vault with those sensitive values. Now on to pipelines. I have three different pipelines in my specific code example, but I'm only showing one of them here. This is my hub deploy pipeline. I'm building a hub and spoke topology. Now, from a resource perspective, this is defined as a build definition. So, project ID and name and so forth. The agent pool, the default is this Ubuntu 16.04 version. You have some control around agent pools you can link to like existing ones through Terraform, the Terraform provider. I don't do this in this example, but there are examples in the public documentation. I give it the path to where my definition files are, where my YAML files are sitting. And then what's important here is I'm telling it that I want the CI, continuous integration trigger, to use what the YAML file is saying is its trigger. So I'm not controlling the trigger through the Terraform code itself when building and managing the pipeline itself, but we're actually effectively pointing or saying whatever the YAML file says is its trigger for this pipeline, that's what we're trying to leverage. We have the variable groups here that we're linking. So the first one is the one with the secrets from the Key Vault. The second one are the general variables that I have for the pipeline, like the subscription ID, the tenant ID, and so forth. And then we're linking it to the repository that we're building brand new as part of this deployment. Now we're going to talk a little bit about service endpoints. And this is a topic that I found a little confusing, to be honest, while I was going through it. Now, it might just be my limitation of understanding for it, but I found it a little confusing to follow. This is what allows your Azure DevOps project access into your Azure subscription and tenant to be able to, say, trigger that deployment and actually create the deployment of whatever you're pushing through your pipeline. So we have, the service endpoint name and all that good stuff. We have the SPN application ID and a password that we are randomly generating as part of that. And then we're linking it to the specific tenant ID, subscription ID, and so forth. That's one option that we have in creating a service endpoint. There's actually several more, so we're going to cover those briefly too. The next option with service endpoints is using OAuth. Now, you see in this example, again, I don't use this in my execution, but this is an example straight from the documentation where we're able to make a service endpoint to GitHub using OAuth, right? But what I find a little confusing with this is that we have this example in the public documentation. We have a code use example just like this, but we do not yet have that ability, if you recall, to import an existing GitHub repo into Azure DevOps. So maybe that's what I found confusing at first. When do I use this versus the other one versus a few more that we're going to cover in a moment? It wasn't clear, especially since the import feature for GitHub wasn't working at all. So that might again be a limitation on my understanding, but I didn't. I had a hard time understanding the proper use of each piece and when. Another example, again in reference to GitHub, is using that personal access token, right? So we have that this personal access token in line. Notice we can set it with an environment variable, so you don't have to have that sensitive piece of information inside your code specifically. You can pass it in line or as part of the environment that you're executing within. And then finally, we have another option with a GitHub app type of service endpoint. Now, this is a little bit different. I haven't used this, but again, because we can't import it from GitHub, I think these various service endpoints around GitHub are just constructs that are there in place so that they're ready to be utilized and they're available once the GitHub interaction of importing will work or that functionality has been lit up. So this is another option that we can leverage. I haven't explored it too much, but we have at least these exact code examples from the public documentation. So that's enough talking. Let's actually see this in action. So if we get out of our presentation, go to our, first we're going to go to the portal, and we see we're going to create a new folder in here with a new key vault with those sensitive variables and be able to execute there. And then on our Azure DevOps organization here, we're actually going to create a brand new project. So it's not here. This is an old one that I have. So we're going to start that execution. So before we kick it off, I'm going to just take you quickly through some of the files that I have here. So we have our tfvars file. This is where we're actually putting all the variables or the values of those variables. So it's all in one spot that I want to be able to leverage for the various pieces of my code. Now, if you take a look at my blog article I wrote about the Azure DevOps Terraform provider, I explain how I have my code organized here. You could have all of this code on a single Terraform file. Nothing wrong with that. But personally, I find it easier mentally to keep myself organized and keep things straight in my head by breaking out these files individually to what they represent or what they're going to execute for or against. That way I know if there's a problem, I have to go to this file or this file and so forth. So starting with the project file, just like we saw in the screenshot, we have our description and all that good stuff. We have the features that were set, and we have that other option down here for as a separate resource for the project features. Now I have that commented out because I'm doing it in line, but it's here for reference that either way we can do that. Next, we go over to the repo code, just like we saw in the screenshot on the presentation. We're creating a brand new repo. If we go to tfvars, we can see the name that we're going to call it. ADO native repo is the name that we're putting in, and we're going to initialize it. Now down here we have that code example for the import. You can see where I was trying to do an import of one of my public repos here, specifically to get these build definitions in, but I was able to determine and find out, unfortunately, even though the import option is in the documentation, and there's an example for it, that functionality actually isn't quite yet supported. So I still have it here for my reference so that once that the provider is updated and that feature is available, I can just comment out my new repo code, uncomment my existing repo code, and test it again. Next, I have my variable groups that I was talking about. The first one I have here called var group is with a key vault integration. So I'm actually creating a key vault as part of this execution and adding those sensitive values and variable secrets into that key vault. So we're linking it to that here. And then we're also linking it to the service endpoint, which we'll touch on in a moment. Down here, like we showed in the screenshot, these variables are within the same declaration of this variable group, and these are the names of the secrets from the key vault that we want that linkage between. Further down, we have our second variable group where it is not linked with key vault, and we are actually putting in the variables and values that we want available within this. So we have things like our subscription and tenant ID and so forth, as well as some variables around our Terraform state and where we're storing that for reference, specifically for the pipeline. Speaking of pipeline, we have our build definition here, right? Whatever we're going to name it. We have three different ones in here where the path is sitting for those YAML files. We have the trigger that we're going to use the YAML file specifically, and that's going to control the trigger of the pipeline itself. We're allowing and referencing access to those variable groups so that we can pull the sensitive data from the one that's linked to Key Vault, and then the other data points like the subscription and so forth from the other variable group, which is used in the pipeline code to say log into Azure and do Terraform init and Terraform apply against that Azure environment. Down here, we are linking it to our new repo that we're actually creating and then pointing it also to the YAML file itself. So here is the hub part of the hub and spoke deployment pipeline. Down here, I have a second pipeline that's basically identical for the spoke part of the VNet hub and spoke configuration. And then finally, a third pipeline that does the actual peering between those two VNets specifically. Finally, we have the service endpoint. So remember, this is the part I had a bit of a challenge with clearly understanding with some of the maybe limitations in the documentation and examples that were provided. But this is the one that I was able to get working and understand more clearly, where we are providing the credentials for the SPN, so the ID and the password that we have, as well as obviously what tenant and subscription we are actually targeting for this connection. So we'll see what this looks like in the Azure DevOps space as well, just to kind of make that connection for you in a moment. We have the other example codes here, again, commented out just for reference from the GitHub endpoints, whether we're using the personal access token, whether we're down here using the GitHub app specifically. Again, I haven't used those and I was having some challenges with that, but that might be either my own limitation or maybe possibly some functionality that is not currently present. So let's kick this off with Terraform init. I'll make this a bit bigger here. So we see it's grabbing the providers that we're leveraging. So we're using random to randomize that for that password. We're using the DevOps provider. Notice version 001. So again, very first instance or iteration of this. So there are some obvious gaps that need to be corrected, which we will. We're leveraging the Azure provider and also Azure AD, because we're creating that SPN specifically as part of this execution. So if we go Terraform plan var file equals idio.tf vars. So we're passing those variables, the values for those variables in. Give that a moment. So I've already, on my command line prior to the recording, I've already logged in to Azure specifically, and I've already set those two environment variables specifically. So now we have 22 objects that will be created. So let's go Terraform apply. Same thing, var file equals tfvar, ado.tfvars, and then we're going to say auto approve so that I'm not prompted to say yes. I just want to let it execute so that we can watch it as it builds those resources. So let's just wait a moment, make sure this gets kicked off correctly, and then we will flip over to the Azure portal as well as the Azure DevOps space organization so that we can see these components as a result of this execution. So we see it's creating random strings, random integers for iterations over this. It's starting to create the project. So it looks like the project was already created here, right here. And it's created the repo and so forth. So while this is kicking off, because it's going to take a few minutes, especially when it's creating the key vault, that one takes a few minutes. Let's go over to our project. So if we refresh our organization, this is our new project that we've just created. So we can go into here. And before we explore this, if we go back, go to our portal, refresh this, we have a new resource group. So notice that the number, randomized number 306, matches with the project. So we know these two pieces go together. And in here is where that key vault is being created. So let me just take a quick look at the code, at the execution here. And it's still going, so that's fine. So let's go to our project here. First and foremost, we already know that we can't create anything with like dashboards or any of the board stuff yet through the provider. But let's start on the repo and notice some interesting point here. I clicked on a repo. We first go to files automatically. Now notice it's talking about, hey, this is empty, add some code, do something, right? Import, whatever. But we already created a repo, right, in the code itself. So what gives? If you take a look at this arrow here, notice that this repo that it's showing on this screen by default is matches the name of the project itself. If you look at it, you'll see our actual repo that we declared in our Terraform code listed in here as well. So this is a bit of a gap I've brought up to the product team where there isn't a way to tell Terraform or Azure DevOps that we want this repo, the one that we've created in the code, to be the default one. So when you click on repos, you go to files, automatically this is the one that's selected. Because we see it's already been initialized and has our README file in it. So that's a bit of a gap just to keep in mind if you're executing this or planning to use this for a project, that by default it's going to choose this other one and not the one that you've declared within your code. Let's just take a look at our execution, and our execution is done. I just have a bunch of outputs that I'm pulling back to make sure I get the right values coming back, like IDs for certain things, so that I know everything's being passed through correctly. So it looks like we're good there. Back on our project, let's go into our pipeline and into our library. Here we have our two variable groups that we created. The first one is the sensitive one that's linked to the Azure Key Vault. So notice the Key Vault icon or symbol here. That tells you that this one is linked to Azure Key Vault versus this other one that we created that where we populated the variables directly ourselves. So if we go into here, give it a moment to refresh, the subscription will populate. And that is that service connection that we created and the name that we made for that. So we have it linked to Azure Key Vault for the variables. Here's the Key Vault, again, that was created that we saw in the portal. And then these are those secret names that we are linking between Key Vault and Azure DevOps to leverage. So if we would go into the portal, into our Key Vault under secrets, Those are the three ones that we added. So the SPN password, the SAS key for the storage account, and a default VM admin password. That's that linkage between the secret name reference when we're linking it to an existing key vault. If we were to hit add, if there were more in here, you can enable, toggle, enable, disable which secrets we want to include as part of this variable group that's coming from that key vault. Let's go back to our other variable group. This is the one that's not linked to Key Vault, but where we put in the name and the value directly within our code for subscription ID and where we're storing our state and so forth. So both of these are available to all pipelines to leverage as part of their execution. Now, let's look at the pipeline. Notice here, we click on pipelines and we see these three that we created, our hub, spoke, and peering pipeline itself. So it looks fine. But if we were to go into one of them to try to look at the code, we're going to hit this error, right? Because it's not able to find my YAML file in the directory that it's looking for. Why is that? Well, because we created that brand new repo and we don't have the feature or the ability yet to import into from an existing repo. So there's no way for me to get my YAML files into here programmatically yet. I'd have to manually upload them into here. So keep that in mind. You can build the pipeline, but you're going to have to do a little bit of manual work to get your YAML files in here specifically after the fact. Okay, let's go back to our presentation. Oops, let me get to the right slide. There we go. Now let's talk about some of the lessons learned as part of this execution. First and foremost, you need to pre-create your storage account where you're going to store your Terraform state file specifically for the creation of the Azure DevOps project, right? There's other ways of doing this where you want to use Terraform to create the storage account, but then you're going to have to use, from the command line, use Terraform import, get the resource ID of that specific object, and bring that under Terraform management to be all up Terraform controlled. In a real world perspective, most of the time that with customers I've worked with, it's easier just to simply create the storage account manually. It's the one object you're going to create manually. So now you have a universal state location for all your execution and then execute against that. So in this case, I was executing against an Azure storage account. It could be another type of storage account. It could be a Terraform cloud, anything like that. Another lesson learned was that you cannot import a public or private GitHub repo yet. It's not yet supported. Originally, I thought it was not supported just for private repos. But again, I took my public repo after I finished testing my code and everything was good. I made it public and I still could not import it. So that led me down the way of looking at the issues that were listed on the GitHub repo for the provider. And I found from the product team that apparently that import feature is not yet available, even though there's a public documentation with an example of it. So again, a little bit of a confusion there, just to keep that in mind. I mentioned around service endpoints, I found that a little confusing in creating and understanding the proper way or the best practice way to leverage those, what it was needed for, how it needed to link these different pieces together. But that might have just been my limitation, or maybe the documentation can be a little bit clearer on when you use which service endpoint configuration and why. Another point that I learned was how to authorize the service connection to the Azure subscription with permissions on the key vault that I'm creating for an existing SPM. So originally, I tried to create I tried to use an existing SPN I already had in my Azure tenant to leverage for this, and it wasn't working for me. Ultimately, I ended up creating a brand new SPN as part of this deployment and got that working with Key Vault. But thinking about it after going through both of those iterations and examples, creating a new SPN makes sense because I'm executing this Terraform code from my command line, and I'm going to create a brand new SPN that's dedicated to Azure DevOps in allowing it to work with my Azure subscription to do the pipeline deployments. For me, that works in this example. Um, there might be a bit of a challenge using existing SPNs. You need to have like an object ID of the SPN to pass through for that permissioning, and you need to be able to like feed that in maybe as a variable or as a value for a variable. For the simplicity of our demo today, I set the default network access control for the key vault to allow. By default, it should be deny, right, from a security standpoint. But if you don't do that, then you're not able to kind of go into the key vault to see those secrets like we looked at, right? You wouldn't be able to go and check, hey, did it populate that value um, as I expected, right? Because I'm not connected from my personal system into a VPN that's connected to the VNet that the Key Vault is restricted to. So for simplicity in a demo standpoint, I leave it to allow, but that's not what you would do in a production environment. Finally, off of this slide, the SPN password, something I found interesting in the pipeline. Even though we hit that error specifically, if you recall, because it doesn't have the YAML file for the actual pipeline and it threw an error, I manually uploaded my YAML files in the proper directory that it was looking for just to test end to end so that once we can import GitHub repos in as part of the code execution, it will work end to end. And I discovered that the password that's being generated for the SPN, that random provider, of course, it has special characters as an option for it for a more complex password. But I found that if you're using that variable from the key vault into the variable group that's then passed into the pipeline command line, it doesn't like specific special characters. So let me give you an example of that. Let me go to the code and let me pull up one of my deployment pipelines here. So this is my hub deployment pipeline. So here I'm linking to those two variable groups that I have defined in the pipeline for the project itself. So down here, right here, where we are saying AZ login, so log into Azure, and then also do the Terraform plan execution against the Azure tenant for deploying the actual infrastructure that we've defined in our code. This is a parameter. It's pulling from the variable groups. And because this is a variable here, I found that it was erroring out on AZ login, even if I put tenant first or password first or so forth. It I think it didn't like the password value if, say, it had, for example, a $sign in it, because that is a parameter or a variable within this command line itself. So I think it was getting a little confused about that. So by removing that special character and maybe some of the other characters, like some of the brackets, the curly braces and so forth that we use in some command line functions, removing those out of the generated password for the SPN should make that work a little bit better. Okay. Another lesson learned, like we saw in our example, in the live example, when you define a new repo and it's You're telling it this is the YAML file to use, this is the directory to point to, because we want to control everything end to end through code. Because we're making a new repo and we can't push into it or import into it, then you're going to encounter this error, right, that we showed you. So just keep that in mind as they iterate on the provider. When we have the ability to import or ways to get other data in, then we're able to kind of get around this. But for the time being, you're going to have to maybe do a little bit of manual work to get your YAML files in the right directory that it's looking for the actual pipeline execution. You will see this error like we showed if you don't. And yet more lessons learned. Something else that I didn't show because it requires those YAML files in for the pipeline. Currently, it's not supported to programmatically grant the pipeline access to the service connection. So as an example, you have your YAML files in there, you have the pipeline definition there, and now you go to execute the pipeline. The first time you run it, you're going to see this message where it says the pipeline needs permission to access a resource. When you click on that, it shows the pipeline needs permission to access the Azure Service Connection, which is going into Azure. Now we have the permit button in the UI, but we want to do it programmatically, right? End to end, we want to have a full Azure DevOps project Terraform template and be able to roll it out systematically and have everything working and ready to go. That is currently an issue logged on the Terraform provider GitHub repo specifically for that issue. So again, it's a bit of a gap. You're going to have to do a little bit of a manual step in the interim until that's resolved. Okay, let's wrap up with some resources to learn. So if you've seen any of my other Terraform specific recordings, I like to call out the TF-lint or Terraform lint tool from the GitHub Superlinter, because if you watch the little graphic on the right for a moment, what happens is when you have a Terraform file, you could run Terraform validate and everything looks fine, says everything's good. Then you go to apply it, and when it applies, it errors out because, well, maybe that's an incorrect value. Using TF-lint, we see it actually validates against the provider, against the cloud provider, showing that, hey, the value that you put in for this is actually an invalid type. It's not legit. So it supports Azure, AWS, and Google Cloud. Um, there's a bunch of rules available. Obviously, they started with AWS because there's over 700 rules for AWS for this linter, and there's just under 300 rules for Azure today as they're working through the support for that. And for Google, there's one. So again, they're just starting on the Google Cloud rules specifically, but it's a really good tool to include as um, part of your code push, code deployment, your merge requests, that type of thing, as part of the end-to-end process to validate not just the Terraform code, but now we're validating the actual values that we're putting in as part of that execution so that you don't have a partial deployment where it partially fails and partially succeeds, and then you kind of got to backtrack a little bit and correct it. So just a really good tool to keep in mind. Uh, Finally, here's some other resources. Again, if you're familiar with some of my other presentations, I like to list a few. I like to call out the Visual Studio Code extensions by Microsoft and the one by Mikhail that it's now owned by HashiCorp. I wrote a blog post recently about that where it shows the enhancements that HashiCorp has now released in their first release of that provider, that extension rather, so that we get IntelliSense. We get to see these are the properties that are expected. These are required. This is a string required versus a Boolean. This is optional versus required. Really useful extension there, as well as the links on this page. So my personal curated list of Terraform resources that I used when I was learning Terraform, for the last several years. Lots of blog articles, videos, courses, books I've read, things that I found most effective in learning Terraform along that journey. Then we also have a couple of our links for using Azure pipelines with Terraform, as well as more of a step-by-step with the Azure DevOps pipelines as well, to kind of get you started in. Now that I have an ADO project, we want to use the pipelines to actually execute my Terraform code and deploy and manage my environment. And finally, just to talk a little bit about certification. Everyone's interested in the new HashiCorp Terraform Associate certification. So myself, with an MVP, Ned Bellavance, wrote a Terraform Associate preparation guide for the exam. We wrote this before HashiCorp had any of their official guides that they've released. And we've also written it based off our own personal real world hands-on experience using Terraform and specific to the exam objectives and categories specifically. So that's been out for a little bit. It's on LeanPub. A lot of positive reviews about that for people that have used it successfully for passing the certification exam. So I encourage you to go take a look at that. And also, of course, the official guides from HashiCorp themselves, the study guide, the exam review, and some sample questions to kind of get you an idea of what the questions are going to look like, and help you along that road to certification. And finally, last but not least, this is who I am. For those that may not know who I am, my name is Aidan Ermy. I'm a cloud solution architect, and I work for Microsoft. I specialize in Azure infrastructure, among many other things like management and security and governance and BCDR. But of course, infrastructure is code, leveraging things like Azure Resource Manager, and of course, our topic today of Terraform. Prior to joining Microsoft, I was a five-time Microsoft MVP in cloud and data center management. And also, I'm happy to say that HashiCorp has recently awarded me with what they call their HashiCorp Ambassador Award, similar to the Microsoft MVP program, specifically for HashiCorp. I have my contact information listed on the right. Feel free to connect with me on LinkedIn or Twitter. Check out my blog. That's where I write articles like my experience with the Azure DevOps provider for Terraform and many other things that I work with customers and partners on. So with that, hopefully you found this presentation and this recording today useful and of value. Definitely subscribe, like it, share it, and if you have any topics you also want covered, then just shoot me a message, drop me a line, and I'll see what I can do to accommodate that. Thanks for your time.